Okay, I'm showing 9 o'clock. Nobody's here but me. I wonder if I went to the wrong place again. Well, anyway. Okay. We're going to move on to chapter 3 now. Now, chapter 3 deals with geometry. I think you'll find this uh, much more interesting than algebra, but who knows? Okay. Coordinates. Coordinate. Coordinates are points on a coordinate plane. A coordinate plane is a coordinate plane is that. Now, if you were to put a point on any one of these places, they are always. I know always is a long time, but they're always in the form x, y. Okay. Now, the first thing we're going to do is we're going to plot some points, and then we're going to go into something else. Now, this is the y-axis. This is the x-axis. Now, if you're given a point, let's say you're given the point, this is awfully low. Let me see if I can. And we'll see if this is any better. Okay, so if we're given the point that A is 3 comma 2. Remember, this is always the x, and that's always the y. Now, the way we do this is the first number is on the off of the x-axis. So the first one goes left or right. The y-axis is here. So the second number goes up or down. If it's positive, it goes to the right. If it's negative, it goes to the left. So we always start here. This is called the point of origin. And the coordinates of this are 0, 0. 0, comma 0. So we start here and we go 3 to the right because it's positive. 1, 2, 3. And then we go up 2. 1, 2. There's our point, and we call it A. Now, if you're given that B is negative 2, comma 1. Okay, now remember, negative numbers are to the left. Negative numbers, positive numbers. Negative numbers, positive. Up is positive, and down is negative. So if we go negative 2, 1, remember the first number goes left or right. So we go 1, 2 to the left and up 1, and we call that B. Now let's say that C is negative 4, comma negative 2. Okay, and again, we go to the left 4 because it's negative. 1, 2, 3, 4, and down, because this is negative, we go down 2. 1, 2, 3, 4, 1, 2, and that one is C. Don't put the coordinates by the points. It just gets too busy and too. You can do it if you want, but we don't want to make this any more difficult than it is. So let's say that D is 5 comma 0. Now again, these go right or left. Where in the world is everybody? Did I go to the wrong place? Again? Okay, so we go 5 to the right. 1, 2, 3, 4, 5. And the next one is 0. We don't go up or down. We just stay right there. And that one is D. And letter E is 0 comma 5. First number goes right or left. It's 0, so we don't go either right or left. We just go up 5. 1, 2, 3, 4, 5. And that one is E. Okay, this is real simple. Okay, these are, if you'll look, these are called quadrants. This is not particularly important, but every now and then you're going to see this. This is quadrant 1, and we do this in Roman numerals. 1, 2, 3, and 4. And again, not particularly important, but as I said, you're going to see this from time to time. Where is everybody? Huh. Okay. Okay, here we go. And this is super duper whiz bang important here. This is called slope intercept, SLOPE hyphen intercept, INTERCEPT. Slope intercept form is y equals mx plus b. Very, very important. You're going to see this a lot, where m is the slope and b is the y-intercept. INTERCEPT. Okay, whatever number is here. So if we have that y equals 3x plus 4, our slope is 3, and the y-intercept we call b, and the y-intercept is 4. So what would that look like if we were to graph it? The one point that we know for certain is the y-intercept, and that's 4, which is more or less right there. Slope is 3, which is fairly steep, going up and to the right. Now I'll show this on the graphing calculator. If you have one of these things, well, let me do this. First you turn it on. I hope you can see it. And you go to y equals. It's up here in the upper left-hand corner. Y equals, and we're going to put in, what was it? 3x plus 4. 3. Now x is not this. This means to multiply. X is up here where it says xt, theta, and n. 3x plus 4. Now look, before you leave the screen, double check and make sure you put it in right. Now let's go to graph right here. And if you'll see, even as bad as my drawing is, you can see it goes up and to the right and crosses the y-axis at 4. This is the y-intercept. That's where this line crosses the y-axis right here at 4. I know this is going to be kind of confusing at first, but stick with me here. It's gonna make some sense, I hope. So what if we have this? Y equal, oh, before I forget, slope looks like this. Slope, that's M. This is a slope of, looks like a slope of 1, more or less. This is a slope of, probably about 2 or 3, something like that. This is a slope of, probably about 7, something like that. Very steep, going up and to the right. If you'll notice, all these numbers are positive because the line goes up and to the right. Now, if it goes down and to the right, these should have had arrows. If it goes down and to the right, here the slope is about -1. Okay, if it goes down to the right, the slope is negative. And this one is probably about -5, something like that. Okay, now, what if we have this? What if we have a line that's a horizontal line? Here the slope is 0. Now, if you have one that's straight up and down, here the slope is no slope or undefined. Either one doesn't make any difference. Vertical line is no slope or undefined slope. Horizontal line is, excuse me, 0. And we'll talk more about this later. Okay, so up and to the right is positive, down and to the right is negative. Okay, if this is 1, let's see if you're so smart. Let's see you get this one. If this is 1, and this is like 9, 8, 7, 6, 5, 4, 3, 2, 1, then what is this slope right here? It's less than 1, right? That'd be a slope of like 1/2, something like that. You can have fractions as slope also. Remember, it's not going to be negative because negative slopes go down and to the right. Okay. Why is there no one here? Huh. Wonder what I have done. Pretty sure I'm in the right place. It is Thursday, right? It's not Thanksgiving, I don't think. Okay, remember, y equals mx plus b. It's called slope-intercept. Because, why is it called slope-intercept? Because this tells us the slope. M is the slope, how steep it is, and B is the y-intercept, T-E-R-C-E-P-T, y-intercept, right? Right. Okay, so if you're given this, y equals 5x minus 2, what is our slope here? It's the number in front of x, called a numerical coefficient. those words aren't super important, but you are going to hear them from time to time. Numerical coefficient, it just means the number in front of the letter, the number in front of the variable. So our slope is 5, and our y-intercept is this number here, which is -2. So if we were to graph this, it would look kind of like this. The one point we know is the y-intercept is 0, -2. So here's -2, more or less right there. Slope of 5 is very steep, going up and to the right, like that. And if you're not sure, if you got a graphing calculator, put this in your graphing calculator, and it'll spit out something that looks kind of like that. Let me show you. Okay, first you turn it on. I tell you what, I can't tell you how many times I've go to punching on this calculator and look up to see if I've entered it right and forgot to turn it on. Bonehead. Okay, so here we are at y equals 5x minus 2, 5. Remember the x is this one up here, where it says xt, theta, and n. Not this. This means to multiply. 5x, I've already forgotten, minus 2. Minus 2. Right? Right. Look up there to make sure you entered it right. Now we go to graph, here in the right-hand corner. And you can see that even as bad as my drawing is, we're correct. Very steep, crossing the y-axis at -2. Right? Right. Okay. Let me do another one. So if we're given that y equals negative, come on, boy, think. 4x minus 6. Now what's our slope here? Our slope is -4, and our y-intercept is -6. So if we were to graph it, it's going to cross the y-axis at -6, has a slope of -4, very steep, going down and to the right. Probably something like that. Okay. Okay. Well, get this if you're so smart. So what if we have this? If we have 2y equals 8x plus 6. Is this in slope-intercept form? No. Remember, we want y over here by itself. So how do we get y by itself? We're going to divide everything by 2. And that'll give us y equals 4x plus 3. Divide everything up here by 2. So now we have our slope is 4, y-intercept is 3, and if we were to graph it, it's going to cross the y-axis at 3. Steep slope going up and to the right, so it's going to look like that. Then you get to drink your Diet Coke. Today is Thursday, isn't it? Okay. What about this if you're so smart? What if you have 3y minus 6x equals 12? Is this in slope-intercept form? No. Remember, we want y over here by itself. So this is a fairly simple algebra problem, just looks nasty. Kind of like my ex-wife, nasty and dirty. Okay, so what we want to do is first we want to get rid of the addition subtraction. So we're going to add 6x to each side. And we get 3y equals 6x plus 12. Is this in slope-intercept form? No. So we're going to divide everything by 3. Y equals 2x plus 4. Okay, and if our slope here is 2, okay, this is the slope, the y-intercept, and b is 4. And if you were to graph it, it's going to cross the y-axis at 4. Slope of 2 is going to look kind of like that. Okay, this is about as difficult as these problems get, but it's just a basic algebra problem. Very simple algebra problem. And look how old my hand is. It's hideous. Okay. Now you're going to see this on the final exam. You'll probably see a couple of these. If you're given that, let's see. Hold on, let me readjust here a little bit more. Okay. Okay, if you're given that y equals 3x plus 2. Now, how many points are on? How many points are on that line? There's an infinite number of them. There's thousands of millions of them, billions even, because you've got this one and this one and this one and this one and this one. But if you plug in any of these coordinates into this, you will get you'll get one side equals the other side. Now let me see if I can come up with let's say 6, 8. So is this point a solution? Lution. In other words, is this point on this line? Okay, so all we do, remember, this is x and this is y. Super duper whiz bang important. That the first number is the x and this is the y. So all we do is we plug in the numbers. Y equals 3x plus 2. So for x, we plug in 2, and y, we plug in 8. So 3 times 2 plus 2. Now we do order of operation here. 3 times 2 is 6, plus 2 is, and we put a question mark on there, does it equal? And 6 plus 2 is 8, so 8 equals 8. So yes, this point, 2, 8, is on this line. And like I said, you're going to see this, excuse me, you're going to see this problem on the final exam, and I'm going to irritate you with it. Mm-hmm. Mm-hmm. Okay. So what if you're given this? 2x plus 3y. equals 12. Is 3, 2 a solution? Huh. Not one person showed up? I must be in the wrong place. Hmm. Well, I'm sorry. I don't know what happened here. Maybe I pissed everybody off. Okay. And remember, these are always in the form XY. So plug the X in wherever there's an X. So we have 2 times 3 plus 3 times, and Y is 2. Does that equal 12? So this is 6 plus 6 equals 12. 12 equals 12. Yes. Okay. Mhm. Now, how about out of the same equation is -2 comma -7 a solution? Okay, so we have 2x plus 3y equals 12. This is x, excuse me, that's y. So the x, we're going to plug in -2, so we have 2 times -2 plus 3 times -7. And does that equal 12? Now 2 times -2, a positive times a negative is a negative 4. 3 times -7 is, what is that, -21? Does that equal 12? This is -25, does not equal 12. So this one is no. Okay. Okay. You're going to see this one on the final exam. So you might see a couple of these. They like these for some reason. Completing the ordered pairs, or DERED, ordered pairs. Ordered pairs are nothing more than XY, 3, 2, 5, 7, whatever. It doesn't make any difference. The ordered pairs are just this point. So if you're given, say you're given, I think my handwriting's getting worse. Y equals 4x plus 5. Complete the ordered pairs. Okay, this is what you're given. COMPLETE. Complete the ordered pairs. Or the ordered pair. If you're given seven comma y. So we don't know what y is. We're going to figure it out. So we plug in the numbers you know, solve for what you don't know. It's really very easy. We don't know what y is, so we put y equals 4 times x. X is 7 plus 5. So y equals, now it's just order of operation. We do multiplication first. 28 and 5 is 33, I think. So our ordered pair is 7 comma 33. I think. Mm-hmm. So now if you're given the same y equals 4x plus 5, complete the ordered pairs. X comma -3. And remember, this one's always X, this one's always Y. I know that always is a long time, but whatever. Where the hell is everybody? What have I done? I don't know. Remember, we're going to plug in X for X. We don't know what X is. And -3 for Y. Remember, these are always in the form XY. So we put, now we're going to have a fairly simple algebra problem. Y is -3 equals 4x plus 5. Am I right or am I right? I'm right. Now we have a real simple algebra problem. X is over here on this side. So remember, we want to get rid of addition subtraction first. So we subtract 5 from each side. Signs are the same, so we add -8 equals 4x. Right? And now we divide everything by 4. X equals -2. Is this our answer? No. Remember, you have to plug this back into this. So instead of X, we're going to plug in -2, comma, -3. And there it is. Mm-hmm. Now look, let me show you again what does this mean. You plug this into your handy dandy graphing calculator. First you turn it on, go to y equals, and we're going to put in 4x plus 5. 4x plus 5. Make sure you put it in right. Graph it. Okay. Now remember, what does this look like if we were to graph it across the y-axis at 5? Fairly steep slope, and you can see, even as bad as my drawing is, we are correct. Now, is -2, -3 on our line? Because that's what this means. -2, 1, 2, and then, now I've already forgotten, -3, 1, 2, 3, and it is right there on that line. Or if you look at it on my lousy drawing here, you really can't see it. 1, 2, 1, 2, 3. It's on the line right there. And that's what this means. It means if it's a solution, it's a point on that line. Oh, it'd be more fun. Uh-huh. Okay. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Okay. Here we're going to do a table of values. Table of values. So if you have, let's say you're given that y equals 2x plus 1. Our slope is 2, y-intercept is 1. Now what we're going to do is we're going to create the line. Now how do we do that? Remember, any 2 points define a line. If you have any 2 points, you can make a line. Now we're going to use 3 points. And the reason we do that is if you get, let's say, you have a point here, and you have a point here, and you have a point, oh, stupid boy. If you have a point here and you have a point there, that makes a line. But then the third one is way over here, somewhere out of the, not on the line. You know something's wrong. Something happened. So we're going to use 3 just to, the third point is just a double check. So we do this. We do x, y, and xy. Take any 3 points. It doesn't make any difference. Make them easy. Okay, let's make x be 0, 1, and 2. And then we'll find out what y is. If x is 0, okay, x is 0. 2 times 0 is 0, plus 1 is 1. So we have 0, comma 1. Now let x be 1. 2 times 1 is 2, plus 1 is 3. So we have the point 1, comma 3. And now we plug in 2 for x. When x is 2, how much does y equal? 2 times 2 plus 1 is 5. So y is 5. 2, comma 5. Okay. This is real simple. It doesn't make any difference what numbers you put over here for x, because there are billions of them that will, trillions even, that will be on that line if you do the arithmetic right. So let's see. 0, 1 is right there. 1, 3 to the right 1 and up. 1, 2, 3. And 2, 5. 1, 2. 1, 2, 3, 4, 5. Did we make a nice, straight, pretty line? Kind of. Okay, this is called the table of values. Okay. Let's do another one. Those are so much fun. First, take a drink of your Diet Coke. Okay. What if you're given that, where are we? 3x minus 2. Our slope here is 3. Y-intercept is -2. Okay, so if we were to graph this, -2 is down here. The y-intercept is -2. Slope is 3, so it's going to look kind of like that. So now, how do we graph? Stupid boy, y equals. Okay. So if we were to graph this, y equals 3x minus 2. We make a table of values, x and y, and then xy. This one's really not necessary, but now take 3 numbers. I use 0, 1, and 2 because they're easy and I'm stupid. So we put 0, 1, and 2. Now when x is 0, what are you going to have? The y-intercept. When x is 0, you're going to end up with the y-intercept. So 0, 3 times 0 is 0. So we have 0 comma negative 2. That's a 0 there. And then if you put 1 in for x, 3 times 1 is 3. 3 minus 2 is, was that 1? 1 comma 1. Excuse me. And now we put 2 in for x. 6 minus 2 is 4, so we have 2 comma 4. 0, negative 2, we know that's the y-intercept. 1, 1, over 1, up 1, right there. And 2, 4, 1, 2, 1, 2, 3, 4. So we are correct. Mm-hmm. Okay, so if you're given this, that 2y equals 2x plus 6. Okay, is this in slope-intercept form? Nope. Really doesn't need to be, because you can calculate this just as easily, but it's much easier to get y over here by itself. So we're going to divide everything by 2, and we get y equals x plus 3, I think. Make your table of values. X, y, x comma y. Oh, my handwriting's getting worse. And we take 3 numbers. Doesn't make any difference. Let's use 0, 1, and 2 because they're easy. Okay. When x is 0, we're going to end up with the y-intercept, and that's 3. And then when you put 1 in for x, y is going to be 1 plus 3 is 4. When you put 2 in for x, y is going to be 5. So we have 0, 3, 1 comma 4, and 2 comma 5. And again, if we were to graph this, it's going to look something like this. Our y-intercept is 3, slope is 1, which is more or less like this. So let's see. 0, 3 we know is the y-intercept, so we're correct. 1, 4 over 1 up 4. 2, 5, 1, 2, 1, 2, 3, 4, 5. They're all on that line. Those are all solutions to that equation. Well, that's a good Diet Coke. Mm-hmm. Okay. Now this is about as difficult as these get, and it's really not very difficult. We have 3y minus 6x equals 12. Now we want to put this in slope intercept. In other words, we want to solve this equation for y. How do we do that? Add 6x to each side. And we have 3y equals 6x. And that's a plus 12. Is that right? Now we're going to divide everything by 3. And we get y equals 2x plus, excuse me, plus 4, I think. Now here's our equation in slope-intercept form. Now we make our table of values. And we use 0, 1, and 2, plug in 0 for x, and we end up with our y-intercept, which is 4. Now you put 1 in for x when x is 1. 2 and 4 was at 6. And when x is 2, 2 times 2 is 4, plus 4 is 8. So we have 0, 4, 1, 6, and 2, 8. And if we were to graph this, we know it's going to cross the y-axis at 4. Let's pretend that's 4. Slope of 2 is going to look kind of like this. Man, my drawing is terrible. So 0, 4 we know is that. 1, 6 over 1. 1, 2, 3, 4, 5, 6. And 2, 8. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. They're all on that line, so we know that that is correct. And that's about as difficult as these get, where you have to do a little algebra before you can do that. Mm-hmm. Now you're going to find this on the final exam also. They really like geometry on the final exam for some reason. I haven't figured out why, but okay. Find the x and y intercepts. intercepts. Okay, what does that mean? If you've got a line that looks kind of like this, we want to know what the x-intercept is. The x-intercept is going to be right there, and the y-intercept is going to be right there. Now we know that the y-intercept, the coordinates of this are going to be 0, comma, and we don't know what y is. Okay, and the x-intercept is x and 0, because it does not go up or down. This one does not go left or right. So what we do is, to find the x-intercept, T-E-R-C-E-P-T, to find the x-intercept, set y equal to 0 and solve. To find the y-intercept, we set x equal to 0 and solve. Okay? So to find the x-intercept, we set y, that's this one over here, set that equal to 0 and solve the equation. Same thing with the y-intercept. You set x equal to 0 and solve the equation. Okay? So what if you're given this? Get this if you're so smart. Okay, so if we have this, if we have y equals 2x plus 6 find the y-intercept. R-C-E-P-T. Let's find the x and the y. Okay, to find the y-intercept, we already know what it is. It's 6, right? This is the y-intercept. So what would we do? We would, to find the y-intercept, we go y equals 2. We set x equal to 0 and solve the equation. So y is 6. Now, is this our answer? No. They are going to want the coordinates of this. What I do, I have to draw pictures, I'm sorry. The y-intercept is 6. So what is this coordinate? 0, 6. Now to find the x-intercept, we want to find the x-intercept now. So we set y equal to 0. Y equals 2x plus 6. Set the y equal to 0. Right? Right. And now we subtract 6 from each side, and we get negative 6 equals 2x. Okay, real simple algebra. Divide by 2, x equals negative 3. Is this our answer? No. Remember, we want the coordinates. So it's going to be negative 3. X is negative 3, which is more or less right there. Negative 3, comma 0. Right? Right. This is our answer for the y-intercept. This is our answer for the x-intercept. Okay? Well, let's see if we're right. Let's put it in the handy-dandy graphing calculator. Turn it on. Oh, you know what? I know what I did wrong. Stupid boy. Hmm. Mm-hmm. Okay, turn it on. Go to y equals. And we know that 2x plus, no, is that right? Yeah, 2x plus 6. 2x plus 6. Double check, make sure you put it in right. Go to graph. Okay. Here's our y-intercept right here. It's 0, 6. And here's our x-intercept. Each one of these tick marks is 1. So we negative 1, negative 2, negative 3, negative 3, 0. So we are correct. Okay. Y equals cleared out. Okay. Okay. That's all. All right, y'all have a good weekend. Bye-bye. Bye, Bonds.